All right, guys, let's do 7.1 Introduction to Continuous Random Variables. This is going to be quick. It's nice and easy. So we have been looking at discrete random variables. So we were looking at things that were counted, okay, before. So if you look at the number of cards, how many people like ice cream, that sort of thing, you're getting answers that are whole numbers. So these are discrete answers. Continuous answers are measured, pretty much, okay? So they're measured. So things that have units to them also, like velocity, like meters per second squared. And a lot of these, think of what you do down in science, right? So you check the temperature, okay? So degrees Celsius, you get the volume, milliliters or whatever it is. And when you measure these things, you don't jump from one measurement to the next. So let me just take it back. Real simple. If I have 2 liters of milk and I add a little bit of milk, I don't just then jump to 3 liters of milk. But if I do have 2 red cards here for a discrete and I get another card, I have 3 red cards. So discrete numbers go from 2 to 3, 3 to 4, pop, pop, pop. Okay. This doesn't necessarily do this. If I have 2 liters of milk and I have a little bit more milk, I might have 2.1 liters of milk. Or I might even have a smaller amount, like 2.01 liters of milk, or even smaller, 2.00000001 liters of milk. Okay, so that sort of thing is called a discrete, continuous thing. Sorry, my pen just went a little haywire on me there. Let's get rid of that. Those are called continuous, right? Because when we measure them, we only measure them to the point where we can stop measuring. So, for example, when you talk about 355 milliliters in a can of Coke, that's not the exact amount, right? It's probably close to that, right? But it might be 355.1 milliliters or 0.12. If we could measure it to the hundredths or the thousandths or the whatever we're going to measure to, we would be able to note that it's not exact. Okay, so these are continuous things. I did a little thing here on timing, but we'll talk about that in class. No big deal. Continuous random variable is something that is measured. You can take a look at it. It has any value. The probability of it taking being something is all the way up to 1. Okay, so it can be from 0 all the way to 1. And let's just not make things too complicated and just kind of keep track of things. So if I measure speed of cars going down the road, what I'm going to do is use a tally chart. So these are the measurement of the speed here. We don't treat these any really differently than discrete random variables. Okay, so even though we know the car is not going exactly 55 kilometers an hour, we're going to treat it like it is 55 kilometers an hour, and then the next level is 56. So continuous, discrete, it doesn't really matter when we deal with them with the data, but we're going to do some things that we didn't do in the past. But this stuff is pretty straightforward. What you're going to do here is come up with a tally chart. So you need the different size of the bins here. So when we look at this, where you get in an issue, if I said we're going to go from 30 to 40 and 40 to 50 all the way through, where you have an issue is something like, not 30, but let me see here. Where is it? 50. Okay. So if I say we're going from 30 to 40, 40 to 50, 50 to 60, and then we do the tally and we get to 50, where does it go? Does it go here or does it go here? And you might say, why don't we do this? Why don't we go to 49 here instead of 40 to 50? But the problem is when we're looking at actual speed, right? Especially because it's discrete or continuous, sorry, I could go 49.2. And then where's that go? If that's from 40 to 49, that goes to 50. 49.2 has no home. So what we do is we just take advantage of these brackets. So you put a square bracket here and a round bracket here. Square bracket, round bracket, square bracket, round bracket. And that means that this section here is from 30 to 40, but it doesn't include 40. Okay, it goes all the way to 40 and gets very close. But once you get to 40, you jump up to this next bin here. Okay, so 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80. Okay, so that's how we write them like that with a round bracket, square bracket on one side, round bracket. It's really easy to think of, guys, because if you think about this, look at the 40. If it starts with a 4, it goes here. Okay, if it starts with a 4, it goes here. If it starts with a 5, it goes here. If it starts with a 6, it goes here. So when we do this and we get to the 50, it goes in this tally over here. So we keep track of the tallies, and then we're going to make a histogram frequency. So we have the frequency here. We have the numbers on the bottom. And note when we do this, we don't do, I scratched this out, we don't say 30-40. What we do is we put the numbers here 30, 40, 50 with no gaps between them because there's no gaps in the data because it's continuous data. That's why there's a histogram. It's not a bar graph because there's no space between the bars. And when you set them up like that, then you just go, we had two units here, 3, the frequency was here, 3 and then 4 and then 1. And that's just from the tally chart above. And then you just fill this in like this. Okay, and then with no gaps, you have the frequency here, the numbers 30, 40, 50, 60, 70. So this guy here is between 60 and 70. Who's going through 60 to 70? 1, 2, 3, 4 of them. Okay, so really straightforward stuff like that. We can take it one step further. Again, same sort of thing here with the heights. And then here we have the probability distribution sort of already been done for us. And what we're going to do is graph this. And one thing you can do at the end, once you're done with the bars, is put dots here, 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 and sorry, that's the last bit in here. So that's 140 to 150. You make the bars, right? So you make the bars like this. And then you make the histogram like that. I'm going to get rid of these lines in a second. You do the whole thing. And then, oh, sorry. And then, where'd it go? And then, sorry, sorry, let me do that again. You make dots at the top here for each of these, right in the middle. And what you do now, and hopefully this looks, it'll come up in the red, dot, 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 is then you connect these with a line, okay? Just going through, try to make it kind of smooth. Okay, hopefully you do better than I do. Oh, gosh. What happened there? Had a little bit of an episode there. Let me try that again. Let me try that again. Let me see if I can get this. I'm going to blame the poor musician blames his instrument, but I'm going to blame the thing I'm using. It's a little weird. Let me see if I can get down here. Let me try this. Nope, that wasn't even close. All right. That's not me, okay? Trust me. That's on the thing I write with. My teleprompter, or whatever you want to call it. Let's see if I can get this down here. Okay. Note to self, better technology. Anyway, here we go. We got a smooth curve, kind of smooth curve. And you note here that it looks like we could say that this guy here is actually, if we look at all our different types of curves, right? We talked about this sort of thing. That guy looks a little bit, to me, it looks a little bit that it's been pulled to the left, skew left. Okay, so yeah, you have a normal curve that's been skewed to the left. And we'll talk more about that later as we move on to the normal distribution. But that's it. Not much today. Not much going on. Nothing new. Nothing too new. All right, take care.